Hello, everyone. Thank you for joining us. Welcome to the fourth Atlas of Living Australia webinars. My name is Martin Westgate. I'm the Science Advisor to the Atlas of Living Australia. And welcome to CSIRO's Black Mountain campus, which is where I'm broadcasting from, which is on Ngunnawal country. So before we go any further, I would like to acknowledge that we are on the lands of the Ngunnawal people and acknowledge their elders, past and present and emerging. And to welcome you, delightful audience. Today we're here, I'm really excited about today's talk actually. We're here to talk about innovations in biodiversity data management. And just to give an introduction to all these wonderful speakers who you'll be hearing from today, because I know that's the key point why you've all tuned in, is not to listen to me. The reason we're interested in this is that the Atlas of Living Australia is often thought of as a data provider, but we're not. We're an aggregator. So we don't produce any biodiversity data ourselves. We just try and ship it up and share it with the world. And the people who actually do the work and collect and store that data are the many institutions and the people who work in them that collect that data, store it, and provide it to us so that we can share that in turn. And what that means then is that any successes that the Atlas has in sharing data is built on a huge amount of work and a huge amount of vision and innovation by the people who generate and store that data. And so today we're going to hear from members of 3 different organisations. So I'll get them all to wave as we go around. We've got members of the Royal Botanic Gardens in Sydney, so Joe White and Hannah McPherson and Kevin Noakes. Thanks, guys. We've got Larissa Braz-Sousa, who's here at, representing the Great Southern BIOBLITZ and is also at University of South Australia. And then we've got Ron Avery, who's from the Department of Planning, Industry and Environment, New South Wales. And each of those are doing slightly different but equally fascinating things with their data and really demonstrating new ways that big data can be used in biodiversity science. So I'm going to leave it there and I'm going to hand over to our first of our speakers, which is our Botanic Gardens team. So over to you guys.
There we go. Thank you so much, Martin. Joe White here. I'm going to be the first of our 3 speakers, and what a fabulous topic it is for today. Here at the Sydney Botanic Gardens, we've been digitising our National Herbarium of New South Wales Herbarium collection. And I know we've got 3 speakers. I'm hearing this is the first time you've ever done that, but it's been a massive project. And to do justice, there's 3 of us. There's probably, we could have even more. So we'll acknowledge there's many people working on the project. I'm really just going to start off with a scene setter, and then Kevin's going to take us to, I think, where you've got the topic around challenge today, particularly thinking around data management and storage and data processes. And Hannah will bring us home thinking about, or telling us where we're up to at the moment, but also the massive opportunities that we're creating from this big data. So, and we're also tag teaming with a slide. So Kevin's ably supporting. We're going to the next slide, Kevin. So like so many areas of innovation, I think we could look back in history, and those who have come before us have been innovators, and we have a great debt to them. So if we reflect on the collection here at New South Wales, was initiated back in 1853, and it moved into its own dedicated building in 1901. So you're getting a sense of the history. It grew again, and in the 70s moved into what is called the Robert Brown building, which you can see there on the screen. And we house our collection at the moment in these red boxes, around 70,000 of them. We've also outgrown this home, and this home is also not ideal for storing the collection, being a bit too humid, and that's causing some issues. So we had an opportunity where we secured funding for around $60 million to create a new herbarium, and this is us for the future. This herbarium is being built at our Australian Botanic Gardens, and is looking pretty much like that at the moment, actually, with the fly roof and vaults, and we're due to move out later in the year. That triggered an opportunity for us to digitise our collection as part of preparing for the move, and it's been assisting that. It's probably added a little bit to the challenge of the move as well, but it was a great opportunity and we grabbed it. The money that we received for the actual new herbarium hasn't paid for digitisation. We've had to basically fundraise for that, but it has put us in a good position to do this and elevate the work. So if I go back to the journey, 2018, we went out to tender. We selected a company called Picturae. They're world leaders in herbarium digitisation. And they've subcontracted to a company called Alembo, who are doing the metadata transcription for us as well. And just if I take you through there from the Netherlands, they ended up needing to build we needed to build a special room. Conveyor belt came in, and there was a lot of work in terms of the preparation of the specimens for imaging. We started in April 2019. We had a pause with COVID, but we're full steam ahead at the moment. And of our collection of 1.43 million specimens, we're looking at over 1 million will be digitised by the end of October when the collection starts to move. I think a lot of the focus, we've had over 290 people as volunteers in that preparation step. So not all of the specimens were mounted, for example, so we've had to secure them. Not all have had metadata in our database, so we've been applying barcodes and having the metadata transcribed. So a lot of focus has gone on the preparation and the imaging, and sometimes it's those very tangible parts of the project that everyone focuses on. But there's enormous challenge that sits there, and complexity around the data flows and quality control to start with, but all of the different steps that take you through the storing, the managing, and the process steps. And so I will hand at this point, there's a little sample of our images, but I'll hand now to Kevin to talk us through some of those data challenges and solutions. Thank you.
Kevin, I think you're on mute, sorry.
Okay, so I'll also pay my respects to the traditional owners of the lands on which we work and travel. In my case, I'm on the lands of the Darawal. Look, the screen that I'm showing you here is a working copy of my whiteboard as we went through the process of trying to define what we needed to achieve to take data from the output of the work that our imaging partner were doing and turn it into a working data collection. So in the light of what we're talking about here, innovations in data and biodiversity, this is where the data part really comes in. And this is really the part that I've been assisting the program with. While this working copy of the whiteboard is showing a data flow of an individual image as it moves through various stages of having been QC'd, aligning with some metadata, perhaps finding the barcode that identifies that image and then being able to attach that to the image through some renaming, and then ultimately uploading it to some storage appliance. That's all very well when you think of a single image, but if you think of the volumes we're talking about here, so initially we were talking about a 1.4 million images over an 18-month program. So I did a bit of maths on that. That's 2,500 working hours, which roughly works out, you've got to run that process for about 500 images per hour, every hour over the life of the program. So it quickly became a process which had to be done at scale. And that's really where we came into using this mapping process to identify those really heavily manual tasks and being able to automate those. So we've looked at some of those tasks which don't require great amounts of skill, they just require great amounts of time. Extracting barcodes. So the renaming of files, some of the processes related to being able to check for errors in the data as it comes through, duplicate names or badly named data as it comes through, and then just the process of uploading that to our final storage location. And where we've come to there is to support the QC team, the quality control team, with being able to script and automate as much of that as we possibly could. The next challenge then was, having created all this data, and that's in the vicinity of around 70 terabytes of data was to be made available for use by other scientists, international scientists, citizen science, etc. And in the vicinity of about 300 terabytes of mastered data or archived data that came off camera. So that became the next data challenge. And there's two parts of that. There's the low and high latency use cases. Obviously, archive images you rarely draw out of archive, but that data that was to be made available for use needed to be in a form that it could be easily accessed. So we looked at hardware solutions, tape arrays, and storage appliances, etc. But ultimately, the solution demanded really for us to look at some sort of cloud solution. The fact that our collection is all in Creative Commons allowed us to consider the sorts of solutions where we could use the public dataset program. Now, this is Amazon sponsor the storage on the basis that this is a data collection which is in the public benefit. So they provide us with goods in kind storage, and this is the registry of the open dataset collection and our entry on that registry. We use a JPEG 2000 lossless format, and the archives are just a TIFF format there. We then have, of course, the challenge of having stored it, how do we use it? And indeed, the image that I'm showing you here is really some of the thinking we've got around managing the data that this collection represents. So although this is a large science collection, it's also the largest information management problem that we've had to resolve. And indeed, looking here, there are the aspects of course, adding to that collection, managing the data that is represented by that collection over its life, and then making it available through some sort of intelligent search means, the ability for people to find items of interest and then extract them out and use them. So that's a body of work which is in progress for us at the moment. Now, of course, as our hosts, ALA, we're working with ALA particularly to be able to share that data and make that available as an aggregator. But if you wish to find out more, I've included a link within our slide as to how you can certainly get access to the collection as it grows in that storage appliance. So over to Hannah.
Thanks, Kevin, and thanks for having us today. It's really great to be able to share some of our story that's not quite done yet with everybody. So where are we at now? At the moment, we have as of the end of last month, the end of April, these figures are 722,893 images scanned. Most of these are already uploaded to AWS. There's a slight lag while we do the QC before they make it up there, but there's maybe 90% of those are already up there and available. And we, as Joe mentioned before, our undatabased samples, the images, we're using the images to have those records databased, and we now have 330,770 new database records as of the end of April as well. So it's an amazing leap forward for us, and it's very exciting. And with the move to the new herbarium, the first way these images become extremely useful for us is in auditing our own collection and planning for the move. So all the data that's coming out of the digitisation project is helping us to make sure that we track our specimens and safely move them from this facility to the next. So probably not the most obvious outcome when you think about digitising your collection, but certainly one that we're making the most of. Next slide, please, Kevin. It's also probably preaching to the converted here, but it's also a large part of why we want to do this is to protect our collection. So we've had, as Joe said, issues with our building as it's getting to the end of its life, and issues with pest outbreaks, and our new facility is really working towards ensuring our collections are housed beautifully and safely. But having these images also means that we don't send anything that's requested on loan. People will be able to target their loan requests and only handle the items that they really need to handle. Probably next slide, please, Kevin. And ultimately, we want to share our data. We want to share our images. We want people to use our collections. So if the more that we can build the infrastructure to get these images out there and in a really searchable way, which they're not at present, the more people will be able to use this, and also it will help us recognise where we need to build our collections. So I just put a little example here. So people are starting to use our image collections already. This was a little testimonial from someone who asked for a loan that we couldn't lend at this time because we're moving. So I instead sent images, and he's written, I won't read it out, I'll leave you to read it, but he's written that this will completely serve his purposes, and he was extremely happy. So it then also gave us a little charge to think. We have to think a little bit differently about how we curate the collections and how we get the information back from the researchers about updating identifications and things like this. So yeah, there's still problems to solve, but it's opening so many possibilities. So on that note, coming to the end here, but I guess at the end of this, we will have for the first time a complete stock take of our collections. We'll be able to start opening them up really to their fullest potential to the outside world, and we'll be able to start using the big data for really exciting research projects. This little strange image on the side here is just the start of some of the work we're doing with artificial intelligence to try and recognise leaves and partial leaves, to do some studies across certain, I think, with latitudinal change. So thank you.
Lovely, thank you, team. That was amazing. I knew that you were working on this project, but the scale of it is enormous, and to combine it with moving buildings as well is crazy.
Yeah.
Thank you so much for that. If I could ask Larissa to start sharing her screen in place of you, Hannah, that would be great. For those watching live right now, if you're not on YouTube later on, you should have a little question mark in your browser somewhere around the screen. If you want to ask any questions of our presenters today, feel free to pop a question in there. We'll have some time at the end for a bit of an open discussion. So yeah, looking forward to having that chat, and happy to pass on questions that have come from the audience. But for now, we're going to pass over to Larissa to hear about the Great Southern BIOBLITZ. So thanks again.
So hello everyone, can you see my screen? I hope it's working. Yeah, okay, thank you. So yeah, I'm glad to be here. Thank you for the invitation. My name is Larissa Brasussa. I am a biologist and a science teacher from Brazil. and I have always been interested in environmental education and science. So a few years ago, I got the opportunity to come to Australia to do my PhD with Professor Craig Williams at the UniSA, running the Model Monitors program, which is a citizen science initiative. And that's how I met Stephen and Seamus. We were from the same lab. And they invited me to join in the early talks about this great Southern BIOBLITZ. So I'm going to share a little bit about this story and how we are managing this generating. So first, who we are. So the Great Southern BIOBLITZ, or the GSB, is a global BIOBLITZ that runs in the Southern Hemisphere using the iNaturalist platform, which is an open access and free to use platform. The first edition happened last year in 2020, and we had 12 countries participating, including places in South America, Africa, and Oceania. So everything started early last year, just after the City Nature Challenge, or the CNC. So the CNC is a global and friendly competition to feature urban biodiversity in April every year during the springtime in the Northern Hemisphere. So the CNC has been running for 6 years, and Australia participated in the first time last year. So after this event, the Australian organizers realized that an urban BIOBLITZ was excluding national parks, excluding unexplored areas in the country, and also rural areas in Australia. And also the CNC happens in April, which is already pretty cold in Australia. So the Australian organizers thought it would be a good idea to run a BIOBLITZ during the springtime in the Southern Hemisphere. So that's how we organized the first ideas of the GSB, which is an international period of biological survey using the iNaturalist platform that highlights the biodiversity across the Southern Hemisphere, that engages people in science and nature learning in a collaborative way, and that also builds a supportive network of citizen science facilitators across the Southern Hemisphere. So these are the first organizers from Australia. So here we can see Thomas Mezaglio from Sydney, Peter from the Surf Coast in Victoria, Michelle from Redlands, and Stephen, Seamus, and me from South Australia. And yeah, so these are the first organizers, but we also had more people joining from Australia, from Canberra, from other places in Victoria and Western Australia as well. And yeah, as I'm from Brazil, I used my connections to invite some friends who invited other friends. And so our organizers list started growing. So these are some of our organizers from Argentina, Brazil, and Colombia. But there are just a few names here because we had over 100 organizers last year. So including people from other countries in South America, from Peru, from Ecuador, from 4 countries in Africa, and from Fiji as well. So we had monthly meetings via Zoom in English, Spanish, and Portuguese, and we made the logos in the 3 languages as well to engage more people. And as we are international, we are the Great Southern BIOBLITZ in English-speaking countries. We are La Gran Biobusca do Sul in Spanish-speaking countries, and we are a Grande BIOBLITZ do Hemisfério Sul in Brazil and in other Portuguese-speaking places. And the results from last year were surprising for us. So we ran the BIOBLITZ for 4 days, from 25th to 28th of September, and we had over 90,000 observations of over 12,000 species during that time. We also had over 3,000 people participating with the observations, and more than 2,000 people helping with the identifications after the event. So again, people from 12 countries in the 3 continents and 3 different languages. Also, we had over 150,000 identifications on iNaturalist. Sorry. So looking at the data that was generated over this time series, we can see an increase in the number of observations, number of species, and number of observers on the platform amongst the 12 countries that were involved. So this graph shows a time series of the data on iNaturalist per week. And so here we can see 2 peaks, like across last year. This peak represents the CNC in April, and this one represents the GSB. So that's the contribution of data generated on iNaturalist. We can also see this time series for number of species on the platform and number of observers. So again, this peak represents the CNC, and this one GSB for number of species generated, and this for the number of observers. Sorry. And here we can see some examples of the top endangered species observed that were shared by the citizen scientists using iNet, the top community favorite observations, and also like across the 12 countries, and also the top species that were recorded for the first time on the platform for the 12 countries as well. So we had species recorded for the first time in Australia as well, especially some invertebrates. So all the data generated, including all the photos, all the geolocation, all the identifications, so all this data are stored on iNaturalist, which is a free-to-use platform and an open-source platform. So it's a joint initiative of the California Academy of Sciences and the National Geographic Society. So here in Australia, we have a specific node of the iNaturalist, the iNaturalist Australia, which is a membership agreement between iNaturalist, the Atlas of Living Australia, and the CSIRO. So all data collected by the platform is automatically accessible by the Atlas of Living Australia. We also extracted this data from iNaturalist, like we downloaded this CSV, and we used our GSB Google Drive to keep the data, and we used the R environment to run the analysis for the first year. So what's the contribution of our first event? So again, Thomas Mazzaglia, one of our organizers, along with Corey, they analyzed the historical data of iNaturalist in Australia, the current contributions and the future of the platform here. And he recently published this paper where they share some of the contributions from the Great Southern BIOBLITZ. So actually Australia is the 4th highest contributor on iNaturalist globally, based on number of observations, and it has the second highest number of observations per observer. So during the GSB last year, during the month of September, Australia had over 100,000 observations being uploaded in a single month for the first time in the history of iNaturalist in the country. So here we can see like one of the contributions of our event. We also believe, we also believe that the contributions of the go far beyond these numbers. So we connected with people from the countries. We could learn how they run citizen science initiatives over there. And we are growing this network of citizen science facilitators. So here are some of our local organizers from Colombia. These are from Colombia as well. We have some teachers. We have some tour guides from Africa. And on the right are us during the moth night last year. There are some of the photos observed in South America, in Africa, in Australia, some other observations from Africa throughout the event. And some of the major outcomes that we could see, one of the first one was connecting with people, especially during COVID, this hard time, connecting with people from different fields, including teachers, environmental educators, researchers, tour guides, NFPs. Also having new users in the platform, people using iNaturalist for the first time, having new species recorded on the platform, and also enhancing the accuracy of the identification tools. So iNaturalist uses an artificial intelligence. So the more identifications, the better to improve the accuracy of our local our local species identifications on the platform. And also people can learn with the identifications. We also heard many stories from our organizers, like this one from Argentina. So she found a spider in her house and she thought it was a very common species. But when she uploaded the picture on MyNet, she saw it was the first record of this species in her area, first record on MyNaturalist. There was another one, this teacher from Brazil, that she says she really enjoyed having her students involved in the event and recording data of biodiversity in their local area as well. And finally, some of the challenges that we identified after this first event. The first one is keeping engagement, especially amongst the new users between events. So we want to encourage people to keep uploading their photos on MyNaturalist, not only participating just during the GSB, so we want to keep them involved throughout the whole year. Getting the IDs, the identifications, was another challenge. We still have some observations that were not identified on the species level. So we need to connect with more experts in different fields, like plants or fungi, to help us with the IDs on the platform. Monitoring access is another challenge that we are very careful about. So as the iNaturalist is an open platform, everyone can access, which is
Seems like we've lost Larissa there, unfortunately. I don't know if that's just me. It looks like I've gotten it entirely. No, might have to call that. Never mind. That was a shame, actually. I was really enjoying that, but I'm sure we'll be able to get Larissa back online later on. If you can still hear me, Larissa, maybe if you stop sharing your screen and we can move on to Ron. And again, if people have questions for Larissa, we've got time at the end, so feel free to drop those in the question section. Now, I'm not sure how we can kick Larissa's slides off without her being online. Oh, there we go. So Ron, maybe if you try and share your slides. Yep, lovely. And we'll move on to Ron Avery. Thanks so much, Larissa.
I'm assuming you can see that little. Okay, I'll just move that up there. Okay, so yeah, Ron Avery. I manage the biodiversity information systems within New South Wales Department of Planning, Industry, Environment, which is a very big organisation, but provides a few benefits in that. As a data manager, I can work very closely with the planning programs that are using the data. So I want to do, okay. So I just wanted to really take a different perspective on innovation. I guess raise our head out of the details of individual systems and the technology, and to lead you through a set of 6 innovation ideas. So setting the scene, and I think we sort of all acknowledge and see the pressures that are continuing on natural environment, and realising that, you know, one of the main challenges that we have is mobilising data, bringing it to bear on decision-making systems. When we have a look at, you know, some pretty significant audit reports, you know, trying to establish statements about the condition of our natural environment. So here's a New South Wales State of the Catchment Threatened Species report. You know, it's essentially describing the problem. Very few meaningful data sets were available. Endangered populations of threatened ecological communities were not assessed. State of the Environment 2016, little evidence exists to suggest improvement in state and trend, lack of data and information from long-term monitoring. New approaches are needed. the recent review of the EPBC Act, National Conservation Act, again highlights the same message: decision makers, proponents, community do not have access to the best available data and information science. No clear authoritative source, right information is not available to inform decisions. So just a reoccurring pattern, and it's been happening for decades. So really, I guess there's a new focus on the data. How do we better manage data to achieve better decisions? And as I say, I'll just lead you through 6 innovation ideas. And these are not necessarily technology related. So the first is collaboration. So the idea that working together, listening, observing, understanding, discussing opportunities is really the first step towards coming up with really effective data management solutions. Data ecosystem. And so I think you've already starting to get a little sense of there's a lot of applications out there. They are nice to use in many cases, but our challenge really is about how do we connect these individual applications to aggregate information. So I've heard that ALA is an aggregator. Again, I manage the New South Wales BIOBLITZ system, which is again an aggregator, but we also delve into the world of data curation and integrate a number of different products as well. So the typical connection between these applications can vary from a manual periodic data transfer. In many cases, there's no transfer at all. Increasingly, the more sophisticated systems are starting to move towards a read-only sharing of data. So that is, we deliver data between systems via an API. And then we're just beginning the process of moving into that next realm, which is transactional APIs. So being able to move edits from curated data sets back and forth between systems. But at the end of the day, you still need a focus on an understanding of which systems will become the aggregators, the nodes at national level and state level, just so that we can then plug these data systems into decision-making systems. So for New South Wales, BIONet is providing that connection. So there's a lot of work in terms of wrangling new programs, new systems, decision systems to make sure that they are aligning to standards and can receive the data that we're aggregating. The next idea is data value supply chain, and it's pretty simple, and that is thinking of data collections and data products as having a life cycle, and starting with data collection in the field, moving through the aggregation, cleaning, analysis, integrating into business systems and achieving some impact. There's many little blockers along the way, and part of our challenge is really about how do we address those barriers to moving and mobilising data into our decision systems. One of the more exciting innovation ideas is what we call the knowledge pump. And so this is one example, and it can be applied to species data as well. So this one's applied to vegetation plots. So vegetation plots are really our primary observation data, and we spend a lot of time aggregating that data and cleaning it and publishing it. There's a range of structured programs that take that plot data and they convert it into vegetation classification. They use it to underpin the modelling that we use to create vegetation maps, extant and pre-1750. And then deliver those raw data and derivative data into biodiversity assessment programs to achieve data-driven decisions. The feedback process is that to validate a vegetation map or vegetation classification, the logical step is to undertake a structured vegetation plot assessment. That then flows back into the pool of data that we use to update data sets. And similarly, the biodiversity assessment program is generating environmental data that can be again harnessed back into the foundational data set to again improve the quality of the decisions in data products. So what we're now finding is, because we've got such a well-connected system, that we're seeing a drive in investment in data. So for the first time, those that are trying to improve the assessment process or the maps or the vegetation classification, their logical pathways to actually invest in the plot data. So now we have programs that will go out and survey new areas that haven't been surveyed before. Really quite a significant breakthrough. We've always struggled to have investment in raw data. I see a similar opportunity with species surveys as well. And ultimately, the benefit at the end of the day is better environmental decisions, better transparency, I guess ability to base trade-offs and balance those decisions about development versus conservation in a more transparent and balanced way. Enabling others. So this is where we start to get to the techie stuff. So within our BINET system, we have focused quite heavily on building data services, so digital APIs to deliver data out from our system. We structured it in a way that creates a data service for each of our data collections. All of those data services are open and transparent. We deliver data through one API pipeline, so the data that we would deliver our data up to ALA is the same pipeline that we would use for biodiversity offsetting scheme or for RFS, Rural Fire Service fire management programs. So moving it through a single pipeline has been pretty significant. An open pipeline has been pretty significant in achieving transparency and consistency. The other key elements are data standards in data dictionary. So it's really framing the way we deliver our data so that others can innovate against it. So they understand what they're getting, how to use it, have confidence in the pipeline. One program can be developed for one solution, knowing that that same data is used in another program. So there's sort of this logical consistency and cultural knowledge. So I just acknowledging that, the traditional owners have been, I guess, developing knowledge about biodiversity in a way that we haven't done before. And so this is just one example. So the Durrell community traditional owners have a story about the flowering of the Acacia longifolia. So that sort of starts about now, and I think the first whale was seen last week off New South Wales, off Sydney. So the humpback whale migration correlates exactly with the flowering of Acacia longifolia. And just keeping in mind that humpback whale was an important food source for local Aboriginal communities. So this is early days. This is some data out of the iNaturalist system, but we'll wait to see more records going into the system. But you can already see that the data is supporting the observations that were made and carried through in traditional knowledge in terms of the alignment to the migration with flowering. And just to conclude, really, the biggest issue here is that there's a lot of challenges in terms of managing data, and for us to really move forward effectively, we need to really collaborate and solve a problem together. Thank you.
Wonderful. Thanks for that, Ron. That was a really fascinating talk, and it's great to hear about the work you've been doing there. So, look, we have, let's see, another 10 minutes or so in which we can have a few questions. And there's been a lot of questions coming through on the channel, which I know you guys can't see. So we won't be able to get through all of them. Look, just to start then, there's been a few questions about the fact that, Ron, you just talked about some investment in data, and clearly the Botanic Gardens are doing a lot of investment in providing new forms of data rather than just what they have in the past. What's I mean, not to say where that's come from necessarily, but where do you think that I imagine you've been arguing for that for a long time. So what do you think's changed that's been that argument has worked, and do you see that this improvement of data is something that people will continue to fund in future, or do you see this as one-off? How do you see it moving in future?
So I think really where there's a strong benefit and where the information can be connected through to end users, then I think you can start to build a case for the benefit. It's interesting, the imagery is a big issue for us as well. We're sort of lacking a multimedia system. So obviously connecting in with Botanic Gardens in terms of the imagery that they're collecting is part of that ecosystem that we need to develop.
What about you, Joe? Was that a challenging argument to make, to advocate for digitising your entire collection?
Well, I certainly agree with Ron that if you can see the application and you can make a good case for the application for end users, that really helps. I mean, it's been an interesting challenge for us here at the Gardens. We weren't funded to do the digitisation, but we have been leveraging off the fact that we've got this brand new herbarium. And so the bulk of the fund has actually come through fundraising. It's actually taken quite a lot of work. We have had some recent government funding. But it is something you've got to keep working at. And I think from here on, it's then saying, okay, well, what's the value add from that data generation? So what insights can we produce for others to solve a challenge that might be faced by government or the community or the private sector? And I think that's where you do get more traction in terms of getting ongoing funding or supported funding.
Yeah, lovely. Larissa, you are different from the other organisations here in that your work builds on an existing platform, Use iNaturalist. Was that an easy choice to choose iNat, or did you consider using a range of apps, or how did you go about making that decision?
Actually, the first organizers, they have used iNaturalist during the City Nature Challenge. So that's why they decided to use the same platform, which is like very easy to engage with people. So like we can communicate in the identification tool. So like it's easy to engage. So we decided to keep the same one, but in a different approach, but the same one.
And I guess that ties in with what Ron was saying about standardizing who your nodes are going to be in your biodiversity data network and really reinforcing their use rather than a multitude. I guess there's advantages either way potentially, but it's an interesting parallel there. Now let's see. We've had so many questions come in. I really am not going to be able to pass all these on. There's been a few technical challenges, particularly questions for the Botanic Gardens people. There's been questions about whether you are collecting DNA at the same time and how you guys whether you use pesticides and whether you're trying to move away from that or not. How challenging has it been to manage that whole process while moving buildings? Sorry, was that it may have been too big a question.
It was interesting when we went out to tender, we basically put the full collection up for part of the tender to see whether people came up with 3D imaging, etc. But in the end, we've gone for the flat sheet imaging, which is kind of not giving that full breadth. In the time that we've got available, no, we're not collecting DNA information, but we can see that's going to keep the demand for that's just increasing. So that knowledge will build, and we'll keep building that over time. Was there another part to the question?
Something about
someone
pesticides.
pesticides. Yeah, and whether that's something that you're able to move past at some point, or is that still current part of the technology for protecting your collection?
So we do have a kind of a ongoing fumigation process, but it's in a way quite a minor part of our pest management system. So mostly we're using light traps and monitoring, and then freezing collections that are infested. But thinking about this was a big part of looking at the design for the new building. So we have vaults that are separate from work areas, which at the moment we don't have. That will mean that there's less people coming and going. There's different quarantine zones so that we keep the collection areas really pest-free, and then the environmental conditions of the building that have been hard to keep stable in this building as it reaches the end of its life will be much better in the new building as well. So there's there may still be a need for fumigation ongoing, but I think really our other pest management approaches will be what we're mostly focusing on.
Some of the treatments of old stopped some time ago for work health and safety reasons. So we don't have some of those dangerous chemicals. No.
Yes.
Right. Yeah. I used to have an office in the library, and we got kicked out periodically so they could treat that collection. I'm glad not to be there anymore. But look, one last concern is that that someone's raised is that there is, for a standard amount of effort, there is potentially a trade-off between the things that sort of Ron was talking about threatened species and them requiring particular attention as not having a good data record of those. And sort of taxonomic breadth, which I guess the Herbarium is really covering by digitizing its whole collection. And Larissa, you mentioned that entirely new species that had never been recorded before on INAT were in there. And so how does the panel feel about how we prioritize effort into focusing on a small number of species versus trying to cover the whole taxonomic breadth? Is there a strategy that can work there?
Oh, do you want me to go first?
I don't know. Maybe I should.
I'm happy to go. I mean, from our point of view, digitising the collection is really going to be helping us prioritise work and effort going forward. And we will always have a balance between work towards supporting the conservation of threatened species and how they're assessed, for example, at the gardens. But there's also a strong mandate around our work for discovery. So, and we certainly know the job's not done with discovery. So we're always kind of balancing the two and trying to make the absolute best use of our time and resources.
And I'd add in that there's probably a challenge in terms of two aspects. One is connecting. So there are little specialist apps and groups that are collecting information on the less cosmopolitan species. So we need to connect those in so that we're bringing them back into the system. The other is also that when you've got a funded program that's going out to survey, it's usually time constrained, resource constrained. So the better investment you can get in terms of the supply through to an endpoint and benefit, the more flexibility there is to, I guess, explore and search for more species. So yeah, I guess trying to get to a situation where we're less time constrained in our time in the field so that additional species can be searched for.
And Larissa, how
do you... this was one of...
Sorry, go ahead.
No, this was one of our challenges as well. As we ran the Great Southern BIOBLITZ for the first time, we were still learning how to measure and how to look at this data. But that's something very interesting that Thomas discussed on his paper as well about the iNaturalist in Australia. So that's one of the challenges, how we can translate the citizen science derived data into species conservation programs, species management programs. So yeah, I think we still don't have a question for that, but that's one of our challenges.
Well, more data can't hurt, right? So always a good place to start. Lovely. Look, thank you, panel, for joining us today and for speaking about your work. It's been really fascinating. I think this is as good a time as any to leave it there. Apologies to anyone watching if your question wasn't asked. I tried to cover as much as I could. But yeah, thanks for your time. Thanks for watching.